All right, we're going to continue our discussion of log functions, and we're going to find antilogarithms with a calculator or a table. Now we've got 14 previous videos that are linked in the description for your ease, okay? When we find the common logarithm of a number m, we find an exponent x, so that 10 to the x equals m. When we find the antilogarithm, we reverse this process. We start with the exponent x, the logarithm, and find the number m, that m equals 10 to the x. So look at it this way. Given log base a of x equals m, the antilogarithm of this m is the number x, so that x equals a to the m. So with real numbers, given log base 2 of 8 equals 3, the antilog of 3 is this 8, so that 8 equals 2 to the third. See? Does that make sense? All right. So we're going to do this a couple of different ways. We're going to do it with a calculator that has an INV inverse key, or it doesn't have an INV inverse key, and we're going to do it on a table. All right? So on a calculator, there's generally no key marked antilog. So instead, calculators have this inverse key, this INV. And pressing INV and then pressing log will give the antilog. Isn't that easy? There might even be a key that says 10 to the x that'll help find the antilog. Now, if neither of these keys, 10 to the x or the INV key, are on your calculator, you can use y to the x. You can raise 10 to a power, okay? So here's what you're going to do with the INV key on the calculator. If we want to find the antilog 3.2546 on a calculator with that INV inverse key, we enter that number and then press INV and then press log. And it'll tell us it's approximately 1,797.2149. Now, what if you don't have that INV key? Well, then what you're going to do is, without that key, you're going to enter a 10 first. Okay, that's the very first thing you do. Then you're going to press y to the x, and then you're going to enter the number. And you're going to get the same answer as if you did have that inverse key. All right? So if you want to freeze the screen right now and write down this info in your notes, that might be real useful. Okay? All right. So if we want to find the antilog negative 2.36589 with the inverse key, you might have to put a closed parentheses first, because your calculator may not let you put a negative and then a 2, okay? It may want you to have parentheses around the negative number. So you can put a parentheses, negative 2.36589, close parentheses, press INV, press log, and you'll get your answer. Without the INV key, we're going to enter 10, we're going to press y to the x, we're going to enter our negative number, and we're going to find our antilog of this number is approximately 0.0043064. All right? You can try this. You can pause the screen and try this on your calculator, whichever one you have, with or without that inverse key. All right? All right, so we can use a common logarithm table to find antilogs. Now, if you saw the previous video, we talked about common logarithm tables, and what we do in this case to find the antilogs is we just reverse the process for finding them, okay? In the previous video, I showed you that if we wanted to find 5.93, we find 5.9 and the 3, and we find out where they intersect. And they intersect right here at this point 7731. What we're going to do now is we're going to find the 7731 and then go outward. See? So we're going to find the number here and then go outward. See? We're going the opposite direction than we did in the last video. So if we want to find the antilog 2.7251, what we do first is we write it in scientific notation. So we've got 10 to the 2.7251. And we separate the 2 away from the decimal point and the 0.7251 on this side, so that's a plus. We can rewrite it as 10 to the second power times 10 to the 0.27251 power. Using the table, we find 0.7251. So we look around this whole table and we find it right here. And then we move this way and find it's 5.3. And we go all the way up and see it's a 1. So we know it's 5.31. We still have to deal with this 10 to the second power. So what we do is, in scientific notation, we've got 5.31 times 10 to the second power. See? Because we did this part. So now we can move the decimal point over. Because of this 10 to the second power, it's 531. See? We move it over this way. So we split this 2.7251 into 10 to the second power and 10 to the 0.7251. We found the number on our table. We went outward and up and found out it was a 5.31. When we dealt with our 10 to the second power for scientific notation, we moved the decimal point. Okay? Does that make sense? All right. Now, we talked about characteristic and mantisses in the last video. If you didn't see it and you become confused, click in the links in the description and go back and watch that 12.5b so that you know what I'm talking about with the characteristic and mantissa. So, to find this one, when it says it's got 7.7143 minus 10, we can see the 7 and the minus 10 right away. So our characteristic is a -3. We can see our mantissa is 0.7143. So using the table, we find that 0.7143. I found it right here. So I went this way and I found a 5.1, and I went up and I found an 8. So I got a 5.18. So now in scientific notation, I've got 5.18 times 10 to the -3. See, because of our characteristic. Taking it out of scientific notation and moving the decimal for that -3, we get 0.00518. All right? See how I did that? Now, what if it said to find the antilog -2.2857, and we're supposed to find the antilog of this number, but the number is given so that the mantissa isn't clearly visible. So to find the mantissa, we're going to add a 10 minus 10. So here's our number, and we're going to add, we're adding, see there's the plus sign, 10 minus 10. Now what we're going to do is we're going to change this parentheses associative property, right? We regroup them. So now we've got the parentheses around these two numbers. We haven't changed the numbers, we just changed the parentheses, didn't we? So now when we add the -2.2857 plus 10, we get 7.7143 minus 10. Now can you see our 7 minus 10? That's our -3, just like up here, isn't it? So look at the number we've got. This is 7.7143 minus 10. It's exactly what we've got here. So we could just solve this like the example above. We could do the exact same thing. We look for the 0.7143 on the chart. We find out it's a 5.18. We know that the characteristic is a -3, so for scientific notation, see, we move the decimal point to get 0.00518, and we can see the characteristic and we can see the mantissa now. So by adding a 10 minus 10 here and regrouping, we can find the characteristic and mantissa. All right? Now, there's one thing I want to show you so that you're not confused before I wrap this up, okay? You might see a key that says IN. This is not the same thing as the INV, okay? It's not an IN, it's an LN, all right? So I don't want you to be confused. This LN key is not the INV key. It's completely different. We're going to be using these in some videos coming up. This LN key is used for natural logarithms. I'm going to talk about that in 12.8a in a few videos, okay? Because we're only at 12.5c right now, all right? So it would be like log base e of x would be L of n of x, okay? And we'll get into that. So don't confuse this LN key for the inverse key, all right? I want to make sure you knew that. Our next video is going to be 12.6a, and we're going to talk about linear interpolation. And there's going to be a link to those 14 previous videos. And if you haven't seen the last few videos and you're really confused, you need to go back to 12.5a at least And there's links in the description so that you could just go to them, because that'll clear up any confusion you might have. If you're still confused, then you didn't go back far enough, okay? So remember what I always say. It's easier to climb a ladder if steps aren't missing. You can still climb it, but you're going to struggle, all right? It's so much easier if all the steps are there, all right? So you could take a few minutes to watch some videos to get rid of all your confusion and relax. Relieve some stress, all right? I hope you're doing well, and I'll see you next video. Bye.